So conditional probability is just the probability that one event occurs given that another event already occurs. And here I'm using X and Y to represent those events. So the probability of X happening given that Y has happened would be written this way. And here's the formula for calculating that probability. You could also write it this way if you wanted to. This is pretty useful because it lets us think about the likelihood of something happening given that we know that something else has happened. So it lets us take into account other events. Here is a good example that kind of shows the process you'll want to use when thinking about conditional probability. So here we have a teacher who asked 60 of his students whether they prefer cats or dogs. And there's a table. So what's the probability that a student who prefers cats is female? So we want to know the probability that a student is female given that they like cats more than dogs. And that's what we've got right here in our second box. This is just talking about identifying those events. In this case, we're looking for the probability that somebody is female given that they prefer cats. So our X in our formula is being female, and our Y in our formula is preferring cats to dogs. So now let's use our formula. What we want for our numerator is the number of females who like cats. And in our table, I'm going to highlight that in green. That's right here. Here's our females who like cats. This little symbol here, this upside down U looking thing, is called the intersection, and it means both. So the intersection shows where both of those events are true. For our denominator, we just want the probability of a student liking cats, preferring cats, or the number of students who do that. So where are our students who prefer cats? Right here, this 25, that's equal to the 10 plus the 15. So then our probability is equal to 15 over 25. That simplifies to 3 over 5 or 6/10. So we could say, according to this table, if somebody prefers cats, there's a 60% chance that they are female. So slightly more likely that they're a girl than a boy. But that's just from the data in this table. And this is just a survey of 60 students. So it might not represent the whole world, but that's what we can infer from this table. Let's look at another one. Why don't you pause the video and see how much of this you can figure out, and then hit play when you're ready to see how I interpreted it. So I've identified my events here. I'm looking for the probability that somebody who has a headache didn't take medicine. And so to find this probability, I'm first going to look for the intersection of people who didn't take medicine and have a headache. So people who both of those things are true for. And I've highlighted that in blue on my table, the intersection of people who didn't take medicine who have a headache. So that's 5 people for my numerator. What about the denominator? That's just going to be the number of people who have a headache. So let me highlight that in red. And it looks there's 25 people who have a headache. So this tells me I can simplify this to 1 out of 5. That 1 out of 5 of my people who had a headache chose not to take medicine. We could also write that as 20%. So most of the people who had a headache took medicine. Well, not everybody thinks about probability using tables, and you don't always have to use a table to find these results. Some people just like to use the formula. So let's try out just the formula here for a couple of examples. So we have one example here that says, for a standard deck of cards, find the probability that a randomly chosen black card is a king. So we're looking for the probability that the card is a king, given that it's a black card. So we're going to want the number of cards that are both kings and black cards and divide that by the number of black cards. Well, how many black kings are there in a deck of cards? If you know your cards, you know that there's 2, the king of spades and the king of clubs. So there's 2 of those. And then how many black cards are there? Well, half of the deck is going to be black. So that would be 52 divided by 2, which is 26. So our probability is 2 over 26, which simplifies to 1 over 13. Why don't you pause the video and try out the next word problem on your own using the formula. Hit play when you're ready to see the answer. So to find this probability, we want to divide the probability that a student likes both math and English by the probability that they like English. So our word problem tells us that 60% of the students like English, and that 45% of the students like both math and English. So we're going to be dividing 45% by 60%. I'm going to convert that to decimals just to simplify things a little bit. And if I wanted, I can even write that as 45 over 60. I just have to multiply both the numerator and the denominator by 100 to move the decimal. And you know what? I know that 45 over 60 is the same thing as 3/4, because that's 3/4 of an hour. So if a student likes English, the probability that they also like maths is 3/4. Or we could say 75%, whichever you prefer. So you can use either tables or just the formula to find conditional probabilities. It's just important that you be able to interpret both tables and word problems. First, identify those events, write down your formula, substitute, and solve.